So we got a packed session for you today. I'll try and minimize the amount of small talk, even though I love doing that. Welcome to the session with the longest name at VMworld, Architecting NSX for Business Critical Applications for Security, Automation, and Business Continuity.
Wow.
Nice to meet you all. Before we start, I have a short poll for you. There's some echo here. I want to know, if you may, by raise of hands, how many people here are vSphere experts, VM admins, VMware guys, vSphere guys?
Wow.
Okay, let's say 80% of the room. How many are NSX experts, or NSX is their main job? Okay, say 5%. Do we have any DBAs, app owners, people that are responsible for the databases and the applications? Okay, okay, thanks. So we tailored the session for this.
Good.
No, these are common slides throughout the virtualizing app session, so I'll just pass through them. Interesting slide just on this. This is a survey we did last year with our customers, checking to see which applications have been virtualized, critical applications. SQL, as usual, is the most friendly and virtualized critical applications with our customers. I can tell you there's another survey we did this year. It's going to be published. Also, it's very similar results. Disclaimer. Okay. About me, my name is Niran Chen. I am a staff solution architect with VMware's Business Critical Applications team, alongside Sudhir here, that will introduce himself in a second. What I do, I'm responsible for Microsoft Business Critical Applications. So I build solutions around SQL Server with VMware, vSphere, NSX, vSAN, all the nice stuff we do. Also write the best practices guides, meet with customers, and go around and talk with customers also in conferences. Also VCDX, if anyone is a VCDX aspiring VCDX, find me later, can talk about it as well. Along with me is here Sudhir Balasubramanian.
Thank you, Niran. And I'm not a VCDX, and I don't do Microsoft. I'm an Oracle guy. So I am a staff solution architect. I specialize in Oracle technologies. I work for the same team as Niran. I have a past life too. I was an Oracle DBA architect for close to 20 years. I am also experienced with EMC SAN technologies, and that's the book that I released, a new version of that.
Yeah, Sudhir is the Oracle master at VMware. So any Oracle question or discussion, Sudhir is probably involved or leading it.
Excellent.
Now, what we did here today, so there's lots of sessions and information about NSX going around. What we focus is the critical applications. So we built for you a session that first of all describes what are the considerations from a critical application owner or DBA or anyone that's from the application side and the BU side with our customers with NSX. We're going to have a bit of overview on business critical applications, a bit of overview about NSX. We're not going to go deep into what is NSX. There's enough information out there about it. We're going to talk about automation with business critical applications and NSX. Reason is automation is key with NSX, especially with the applications themselves. And then, there's quite a few use cases and demos that we have and use cases we're working on with NSX and applications. We chose one that we really like with Oracle, stretched Oracle across sites. Very cool demo that we're going to show here at the end of this session. And we're going to leave some time for quick Q&A as well. So a few words about business critical applications. What is a business critical application? And when I speak with customers, I usually make the division, or I usually say there's two kinds of virtual machines. There's your general population virtual machines, that you virtualize for consolidation, for density, and you have your critical applications, your special virtual machine that have special requirements. A business critical application running on a VM or not is an application that sits in the revenue path for the company. Maybe sitting in the revenue path. The business may be dependent on it. Business processes, or if it's down or unavailable, it could be a resume generating event for you. That makes it also critical. And these critical applications has very specific requirements that the architecture, when you design around them, the architecture of them is derived out of it. And anyone that's looking into VCDX knows these design qualities. So availability, for example, availability needs to be highest as possible, performance as well. These are the top priorities usually when you virtualize critical applications. But also recoverability, scalability, and security have specific requirements. And the interesting part about security, and I'll throw networking on that as well, is that usually the app owners, they shy away from this. So when we talk about network virtualization with app owners, they usually shy away from the subject. We're going to try and change that now in this session. So let's talk about business critical applications in NSX. Why do I care? What does that mean? First, let's start with what is NSX. NSX is cool, yeah. But since we are in a technical session and we try to go deep in this technical, let's talk briefly about what is it. So NSX, first of all, relies on network overlay. It's a network overlay technology. It relies on VXLAN. VXLAN is basically 50 bytes added to each packet that ESXi hosted parts of VXLAN send and receive. And that's the network hypervisor, right? What is the network hypervisor? On top of that, we basically build logical networks or L2 networks. Those networks, when you connect virtual machines to them, they communicate with each other on those logical networks. Now, the VXLAN is basically an additional header, just like very similar to VLAN. So all the virtual network information is in those 50 additional bytes. To route between this network, NSX provides also logical routing. Most routing capabilities will be done using distributed logical router, the DLR. You probably heard that quite a few times here. Both the VXLAN and the logical routing are added VIBs, added modules to the VM kernel of the ESXi host. So basically, it's the VDS, the regular VDS that you have on the ESXi with added capabilities. And that is also true for the logical firewall. The logical firewall, distributed logical firewall, is the way we do micro-segmentation, right? It's east-west inspection. It inspects on the VNIC level. And again, this is part of the VDS. So we basically, with NSX, we make the VDS, the distributed switch on the ESXi host, a super switch that does all these nice things. We also, with NSX, provide logical load balancing with edge devices. And there's additional services that NSX provides, like network address translation, VPN, there's spoof guard, data security. NSX does all these things on the virtual networks. So virtual networks, routing between them, firewalling, and additional services. Because this is virtual, this is all programmatically controlled. Very important. We can templatize it, we can save it aside, clone it, move it, all the stuff we do with virtualization. So we do this on the network hypervisor. Hope this makes sense to all of you, so we can move forward with this session. So this is the question that I get. We go and talk with app owners. I speak a lot with DBAs. I speak a lot with guys that are responsible for the application. And I talk with them about network and security, and they usually say, why do I care about it? And then I contrast it with x86 virtualization, so it makes more sense, and I start getting more interested in what they can do. With x86 virtualization, we got the x86 hardware, and we got on top of that the hypervisor that allows us to run virtual machines, and on top of that we got the applications, your critical applications. Now, when we talk about best practices and how to run critical applications with these guys, most of the stuff that we do is on the hypervisor level, which interestingly enough, those app owners usually don't touch. I mean, We talk about hyperthreading, NUMA, power, how to set the power, stuff about the DRS, vMotion, all this nice stuff that we need to set up in a certain way for critical applications. While they don't touch that, they always want to know about it. Obviously, because their applications runs on it. There's also things that they need to do on the VM level, right? How to size it, where to place it, what configuration. These are the things that app owners do care about. Now, take network virtualization now. We got the transport layer, which is the physical network. On top of that, we have the network overlay that I explained what it is. And we create virtual networks on that the consumers of that are your critical applications. Where are all the considerations are? We got some considerations on the physical side. Generally speaking, the network, the NICs, what NICs are there, we're going to talk about it in the next slide. And we also have considerations regarding how the application should consume network and security using NSX. And the general idea is automation and security by default. Baking the security networking to the app, and now the app owners start to actually be more interested in understanding what that means. There's a nice demo that we show at the booth. Just come and we'll show you some stuff that the DBAs, for example, can take advantage from security that they didn't do until today. So let's talk about actual considerations for performance. So when it comes down to an NSX, for it to work, all you need to have is hyperconnectivity between the hosts that participate in NSX and the ability to run, we say 1600 size MTU packet size, jumbo frames. Even though it's 1550 or something like that, we round it up for 1600. That's all you need for NSX to work. There's nothing else. So troubleshooting is on the physical level becomes easy. It doesn't matter if you have L2, L3 networking going on between your physical host, all you need is hyperconnectivity. Now, from a performance perspective, and performance, critical applications performance is the highest priority. There's some things you might want to have on the physical NIC so that it would be performant in the highest level possible. Generally speaking, obviously, throughput and latency of the physical NIC, these capabilities are important, but also there's some features that you might want to have. TSO, for example, for TCP segmentation offload on the hardware. VXLAN offload. This is an interesting one. Not a lot of cards yet support this, but VXLAN offload basically allows the encapsulation and decapsulation of VXLAN to happen on the hardware. Think about, again, contrasting to virtualization. Think about, hardware virtualization assist stuff, right? It helps it happen faster, reducing network latencies. RSS, receive side scaling. This is something that's important across the board. If you read my our best practices guide, RSS is something we usually say enable on the guest OS. So we also, I would say, it's important on the NIC itself. Basically, it allows networking to be processed by all the physical CPUs of the host, right? Instead of just CPU 0, core 0. So RSS is a good feature to have, and also LRO, which does basically what TSO does, but backwards. These are the hardware performance consideration for critical applications utilizing NSX. Now, when I talk with app owners, they just usually they have specific questions regarding availability, right? So if I put my stuff on network hypervisor, does it mean if the network hypervisor fail, my critical application fail? What about dependencies? Is my application now dependent on additional components? What are the dependencies in NSX? So usually I use this slide to explain the availability perspective of using network virtualization. First of all, so NSX is abstracting out the data plane from the control plane from the management plane. The data plane is where the packets move, and that's the most important thing, right? Because if packets stop move, networking stops working. Packets move, networking is working. Data plane, we got the distributed firewall, the additional module on the DVS. We got the distributed logical routing, distributed switching, and A data plane is also on the edge devices. There's some edge devices, and I'll touch that on the next slides. What about edge devices? But everything is done distributed, which means that, take for example, distributed logical routing. All the E6i hosts show the same router, the same default gateway to the virtual machines using the network, the logical network, and it's distributed. So if a host fails, just everything that on that host gets affected. Obviously, vSphere-J or any other availability technology will take care of that. The hypervisor does not fail. It's distributed. That's the main idea. When it comes to the control plane, we got the control cluster of NSX. That is what controls the routing and distribution of routing, ARP suppression, stuff like that, on all the E6i host, on the routers and logical switches on the E6i host. And this is not in the data path. If this fails, which is the controller, the packets continue to move. It's just that new things might not get, might stop working. We won't be able to create new things. But that is also very highly available. You deploy a cluster of 3, and it's slicing the jobs between the cluster. If one of them fails, the other ones take over. Very highly available system, but still not in the data path. Same for the management plane. We got the vCenter and the NSX manager on the management plane, which provides UI access and API access. And also, the NSX manager deploys all the different components for NSX. Again, not in the data path. If it fails, packets continue to move. Meaning, your critical applications owner should not be worried that the hypervisor will crash. The question that I used to get also in 2004 when we started talking about virtualization, right? On x86 virtualization. Now, when we talk about critical applications, it's many times, it's multi-tier applications. So, if there's, for any reason, one component of your application that is physical and the others are virtual running with NSX, so how do I connect them, right? What are the methods that I can connect them? There's multiple things we can do to connect them. I'm not going to cover all of them. I want to cover a few of them and give you our recommendation. So in this example, we have a database that's still physical. I don't know why. First thing you might want to do is virtualize it. But if it's yet to be virtualized for some reason, the way to connect it from the distributed logical router is, first of all, using routing. So we'll use edge devices, which basically is our virtual machines that provide different stateful services, but also provides routing and connectivity on-off to the physical world. And in order for that to be highly available, we can deploy that in multiple ways. First, we can deploy it in a edge A mode. So we deploy 2 edge devices, and they basically replicate state between them. And one is active, the other one is passive. If one fails, if the primary fails, the secondary takes over. It takes a few seconds. First challenge with it, that few seconds in networking world might be a long time. But still, this is very highly available. And one other limitation with this deployment model is that the throughput is limited to a single edge device, so up to 10 gigabits, right? So when it comes down to critical applications, there's another method we can use. It's called ECMP, equal cost multipathing, where we deploy up to 8 edge devices. And first of all, the throughput now can be up to 8 devices that are active at all times, so up to 80 gigs. Also, resiliency-wise, this is multipathing. Resiliency-wise, all of them are active, meaning there's no failovers going on, just path failover. So it's pretty instantaneous. You need to design your network accordingly, but this is pretty instantaneous. And if you need stateful services, which this does not allow, you just deploy additional edge devices for those stateful services, like load balancing or NAT or whatever you need to do. Well, NAT, not exactly, but load balancing. In any case, that would be our recommendation for most critical applications to connect to the physical world using ECMP. Again, this is a deeper design discussion. There's a lot more going into this, but generally speaking, that would be the idea. There's also the ability to bridge, not using an edge device. That is not the way I would choose in most cases. We say at VMware, when in doubt, route. Okay? Because most most times you don't need to have bridging, like L2 adjacency between different components of the application. Routing is totally acceptable. And this challenges us with this from a design perspective and complexity that I won't go in from lack of time here. Moving on, switching gears, microsegmentations. What are the kind of considerations when you want to do microsegmentation? Anyone here that doesn't know what microsegmentation mean? All of you know what, right? All of you know what microsegmentation is? Okay, good. Saved me quite a bit of time now. So, first of all, every critical application has its own security requirements, okay? So it has its own ports that are required between the applications. It has its own hardening requirements and so on. So microsegmentation is not a single answer to all. You need to think about how you deploy it. You need to address other things other than firewall. And even though microsegmentation brings a security level like way higher than what you might have had before, there's other things the application needs. Hardening from the application side, operating system hardening, the hypervisor hardening, so on. You need to think about it as well. There's additional tools in NSX for security. I know everybody shoots out microsegmentation, and it's huge. But there's other things you can do with NSX for security, like utilizing spoof guard, utilizing data security. There's a lot more you can do with NSX. Take that into account. But this is where the most important thing about microsegmentation I want to say. This is not a flip of a switch. I mean, deploying NSX is totally non-disruptive. I mean, you can deploy NSX. It gives you the network overlay. It does not disrupt your current network. But deploying microsegmentation, it's not something you go into your current environment and microsegment. Because everything will break. You need to think about how you're going to deploy it. Most customers usually choose to deploy it in greenfield and either move stuff into it or build new things into a microsegmentation environment. And I'll give you an example of why. One of our teams has been working with Epic. If you guys know healthcare, that's an ERP, that's the ERP of healthcare. And they worked with them about a microsegmentation model for Epic. And Epic came with the requirements. They said, "Yo, this is what we need. These are the ports. This is the communication that we need between the different components." Guess how much they got it right? And these are Epic. This is their application. They got it right for 60%. So our guys from Arkin, now called VRNI, they came in, they did mapping of this and discovery. One of the main reasons we bought this startup. And they came up with the recommendation for microsegmentation and the path to it. So either you work on each application separately or use a tool that can map and discover and build your microsegmentation deployment path. Just a few words. If you didn't know what advanced services insertion is, it's when you use something like Palo Alto Network. You probably heard about that. And you add like another inspection level, or it could be antivirus, whatever. I'm going to show what's the best way to deploy that. But basically, PAN, for example, will go and deploy its own little PAN instances on each E6i host. And when there's additional inspection to be done, the packet will not be actually sent north-south to the PAN. It will be inspected in a shared memory space on the E6i host. This is just a preview to something I'm going to talk about in a few slides. Let's talk about automating NSX consumption. How are we on time? Good? Good. Okay. Now, what do we automate? And I'm jumping to automation because automation is highly important for consumption with critical applications. You bake the security into the application because, again, not all of us are security folks, right? So we need to bake that into the application so we can secure everything without thinking about every deployment. So what do we automate? First of all, we automate the virtual networks, right? The creation, the management, and consumption of virtual networks. That can be automated. The services, we can automate DFW. The basis for microsegmentation is to automate it. 2 ways I'm going to show. And automate load balancing, for example. So deployment of the edge devices that load balance and deployment of pools and configuration of them. We're working on really cool use cases. Every use case we do demo as well, so that's why I'm saying demos. But we're working on really cool use cases of automating and auto-scaling load balancing with applications like KCP. Really cool stuff. And third-party insertions that I explained just a slide before, we can automate that as well. So why automate? Let's take one exemplary app owner, the DBA, the Superman of the organization. It's not funny. We have a DBA here. So they automate everything. Take, for example, Oracle, right? Well, if you're an enterprise organization, I don't know any enterprise organization with DBA masters there that are going on and deploying everything manually time and time again. They automate the deployment with scripts, with different tools they got, with configuration tools like Chef, Puppet, so on. Automation is something that's going on all the time. Then we can automate also, let's say cloning to test. I want to clone to test with virtualization. It's easy. I go right-click on my database. Boom, I have a test database that I can test on, right? But then when it comes down to security and networking, that is always a blocking task with our app owners. And the reason is, again, they shy away from networking and security. So what you end up in, and we had a panel yesterday about SQL databases, they have a lot of things they need to take care of from security perspective and regulatory requirements, but still, they don't do that because it's hard, it's blocking, it takes time, it can stop my application from working, so on and so on. It's not being done. So we automate. If we automate that, especially with NSX, there's quite a few ways to do that, concentrating on two of them. One of them is using a CMP, that's the holy grail. We talk about database as a service, access as a service, application as a service, go into a portal, click on it, deploy the application. And this is based on, creating those blueprints. Those blueprints has within them all the components the application needs. The IaaS, right, the VMs, the applications to them, and the networking security with NSX as well. The other way is to use, just NSX. NSX has abilities to dynamically secure within it. You don't need to have an additional tool. It has what you need within it. I'll show how to, just a short best practice on that. So dynamically secure and have micro-segmentation even if you don't have cloud management right now. So configure once, consume many times. A few words about NSX with cloud management, specifically our own VRA. You can, deploy your on-demand networks, VLAN, VXLAN networks. You can connect to the DLR, work with distributed logical routers. You don't need to deploy additional routers. You connect to whatever exists on the ESXi hosts. And security groups, and that's what I'm going to show now. Security groups is a way to dynamically secure or set up policy to connect your applications into third-party service insertion. And you do that through, this is the canvas that we build the different service offerings with cloud management platforms. And the cool stuff about it is, as you can see here, I don't know if I have a laser here, we got the VMs. Within them, if you see the boxes here, we got no, it doesn't show it. We got the VMs, we got the boxes, this is the application stuff, scripts, whatever it is, configuration tools. And we got all the networking and security stuff dropped into the canvas. That's how we build the service offering in a cloud management platform. So a load balancer, the VXLAN networks, and you don't see on the canvas here also security groups, security policies, firewalls, all this stuff in the same canvas, deploy over and over and over again. That allows us to have the secure by default baked into the application. So this was a preview. Let's talk about using security groups and what's the best way to do that to secure. So first off, you're going to build those security groups. If you don't know what security groups in NSX is, it's a group that has basically intelligent grouping into it, dynamic membership. You build your criteria into that. Multiple criteria, and whatever falls into the criteria, for example, a specific string, would fit into the group. Then you take that group, You take the group and you nest it in, let's say, firewall, distributed firewall rules, or within security policies. Nice thing about it is that we can pre-create all our security requirements for, let's say, a test database, and then every time we deploy in the test database, automatically it's going to be fully secured. The best practice from that point on would be to use a security policy. And in security policy, as you can see on the right-hand side, the apply to distributed firewall, when you do that, the rule itself is being deployed to all the E6i hosts that has distributed firewall on it. So if I'm going to do that to all the rules that I have on distributed firewall, each packet is going to get inspected by a lot of rules. Okay? We want to reduce that. We have a distributed capability in NSX. So we can change that, the scope, to the policies security group. So if I'm creating a security group, let's say in the source of the rule, saying a database should only be accessed if it has a SQL test within the name, right? When I set the scope to policy security group, only those VMs that fall in the criteria will get also the rule. So each VM inspects only a small set of rules that apply to it. Allow, deny, and that's it. Obviously improves the performance, improves the power of NSX. Best way to consume NSX, in my opinion. For critical applications specifically, that could be also very, very important. And also on the right-hand side, you see there's something called service groups. Instead of just setting up the rules all the time with multiple ports and networking configurations, you do it with service groups. You group different protocols into groups, and you have that easily managed. The same goes for third-party service insertion. You see this is on the top, you see this is a third-party service insertion rule. You see on the right hand, the action is sent to Palo Alto networks for deep inspection. You do the same, utilize the same scope levels, utilize security policies. That would be the best way to consume that. Now we're going into the demo phase. So before we go into the demo phase, I want to just, there's quite a few use cases we are working on our team with NSX and applications. Whether it's recipes for micro-segmentation with different applications, dynamic security membership that you can see where they have papers in the works, load balancing recipes, and the demo we chose to show you today is the last one here, stretching L2 network between data centers to allow Oracle Rack to work between data centers. So before we get to that, Sudhir would give a few words about Oracle Rack, its requirement for stretch between data centers, and then we're going to go into the demo.
Thank you, Master Niran. Thank you. And thanks for calling DBS as Superman, even though I am yet to master the art of flying, but I will try my best to do that. Right? So the use case that we chose was NSX for multi-data center with extended Oracle Rack. So let's just take a moment and look at what a traditional Oracle Rack and an extended Oracle Rack really entails, right? So first question, why Oracle Rack, right? Some of the use cases are high availability. When you want to have the ability to do rolling patch upgrades, that's one use case, right? If you want to do any kind of workload mobility, which means if you have a multi-instance cluster and you want to move workload from one instance to the other, that's a use case. Or if I want to do any kind of load balancing, workload load balancing, that's another use case here, right? And then typically, right, customers, they come up to me and they ask me, okay, why do you guys advocate Oracle Rack on vSphere? I call that rack on rack, right? And the reason is you have a greater uptime running Oracle Rack on vSphere cluster than running Oracle Rack on a physical architecture. Another question that I get from the field, and my background, I am professional services. I worked for 2.5 years in the PSO organization, so I'm a hands-on guy. Another question that comes up is rack on rack, right? Oracle Rack on vSphere, HA. Won't they trample on each other? Won't they tread on each other? And the answer is a resounding no. They are complementary technologies. The other advantage that running Oracle Rack on vSphere gives you is automation, provisioning. I mean, think of the time when you had to install an Oracle Rack, right? You had so much of lead time. Basically, go get a server, put the BIOS in, make sure the BIOS is updated, the firmware, the HBA drivers, the operating system, the Oracle clusterware binaries install, the Oracle database binaries install, create the Oracle database. You see how much time it takes? Using or running Oracle RAC on vSphere, it cuts down the provisioning time, the automation time, from hours to minutes. And that's the Metalink node 249.212.1. Very clearly says, and Metalink is basically the Oracle mysupport.com, that very clearly says Oracle RAC 11.202 onwards is supported on VMware. See, what I would like to focus on for a moment is the interconnect part, right? And typically for any Oracle RAC, see, be that traditional or an extended Oracle RAC, there are 4 genres of network IPs. The first one is public, right, on which people on which only people connect to, the users connect to. The second genre is the private, the heartbeat, where the cache fusion traffic, where data blocks between instances go back and forth. The third genre is VIP, virtual IPs, right? And the fourth genre is called SCAN, single client access name. So think of that as a logical load balancer that all the clients connect to. And basically what SCAN does is it redirects the connection to instances or nodes based on the load. So if you have one node that's heavily loaded, basically SCAN will say, no, don't go to node 1, go to node 2 or node 3. So that's basically what the SCAN does. So the public, the private, the VIP, and the SCAN. And that's what the private interconnect, the slide shows the private interconnect. Basically, it's used for internode, cluster heartbeat, and messaging, basically for cluster membership. Am I alive? Yes, I am alive. Are you alive? Yes, you are alive. So basically, if you have any node evictions, if you have any split brain scenario, that's where you need the cache fusion, you need the cluster interconnect traffic. And if you look at the recommendations that we have, Oracle recommends dedicated network for our private interconnect traffic, and we basically advocate the same. We also say have dedicated network for your private, have dedicated network for your vMotion traffic. So all of the recommendations, all the rules of engagement does not change when you virtualize Oracle RAC on vSphere. See, we spoke about traditional Oracle RAC. Imagine if we had to stretch this Oracle RAC, traditional Oracle RAC, across data sites, across 2 different sites. What needs to happen is you need to have 2 kinds of virtualization, storage and network. You need to stretch the storage across 2 sites, and you need to stretch networking across 2 sites, right? And basically the storage and the network, they need to be universally accessible from all of the sites. None of the cluster requirements for a traditional Oracle RAC changes when you deploy it or when you modify that or when you change that to an extended Oracle RAC across data sites. The only difference here is you used to have shared storage in a traditional environment. Now the shared storage needs to be replicated across different data sites. The other component, the other important component is the latency, right? If you guys read the Oracle documentation, they say 5 milliseconds. Don't go beyond 5 milliseconds or bad things will happen to you, right? With vSphere MSC, and vMSC stands for vSphere Metro Storage Cluster, which is not a product. That's basically a concept. When you stretch vSphere cluster across 2 different sites or multiple sites, it becomes vMSC or vSphere Metro Storage Cluster. You can go either to 5 millisecond or 10 millisecond depending upon your licenses. So if you have an Enterprise Edition license, you can go up to 5. If it's Enterprise Plus, 10 millisecond. If you're looking at the storage aspect of it, right, most vendors typically latency 2 to 5 millisecond. But then when you're looking at the whole stack, Oracle, VMSC, vSphere Metro Storage Cluster, and storage, this is what you have to go with, 5 millisecond, right? So basically what I'm trying to tell you is the latency requirement does not change whether you deploy Oracle RAC traditional or whether you deploy the extended flavor of the traditional Oracle RAC. And we spoke about VMSC, which is basically your vSphere Metro Storage Cluster. So when you have to provide any kind of storage virtualization, there are multiple ways to do that, right? One of the way is the host-based storage virtualization. So basically you use the Oracle ASM, which stands for the Automatic Storage Management, to do the storage virtualization. So basically I'll learn from this side, or I'll learn from site A, or learn from site B. You add it to an ASM disk group, and Oracle does the mirroring for you. So Oracle plays the part of an appliance. Oracle does the storage virtualization for you. Now keep in mind, there's a bit of a CPU overhead when Oracle does the ASM mirroring, because it's Oracle, it's the think time of Oracle. It has to do all of the mirroring, right? It takes away CPU cycles. The second way of doing it is the appliance-based storage virtualization. So basically, your EMC vPlex, your NetApp Metro cluster, HP Pure Persistence, IBM SVC, and our very own VMware vSAN. So I released the paper on VMware vSAN, where I was able to stretch an Oracle rack across the hybrid, so VMware Virtual SAN 6.1 hybrid. So we were able to do that as well.
All right.
Back to mirror.
Just remember, this is an NSX session.
I got it.
Not storage. I'm joking. Okay, now we're going to focus on the networking part of this. As Sudhir mentioned, by the way, Oracle Rack is unique in that it requires the same subnet, the same layer 2 between the sites, so that you can stretch it. Okay, so we need to use something to stretch the network. Either use NSX or something else. We're going to show how to do it only in software. Just 2 words again, just before I go to the demo, because it's important. There's multiple ways to stretch the network with NSX. This is network virtualization, so we can do it multiple ways. Most deployments will just fine with a failover scenario. So you would have, you see, site A and site B. There's no laser here. I need laser. Oh, there you go. Site A, site B. We have the physical infrastructure site A, physical infrastructure of site B. We got the distributed logical router between them. They would be perfectly fine to access VMs on site A through site A and VMs on site B through site A, and only in case of a failure in site A, start utilizing the access directly from site B. Okay? Most deployments are fine with that because this is disaster recovery. That's what we're using it for. There's other ways to deploy NSX multi-vCenter, what we call multi-vCenter, multi-site. The other one of them that we're going to focus on today is what we call local egress. So every VM in each site connect using its own physical network to send packets out and optimize the ingress. So every packet's coming from its own respective site separately. Reason we do this for the Oracle Rack is that Oracle Rack as a clustered application is also not only for high availability, but also a scalability solution. So it needs to have the same performance. You can have it traverse to site B from site A. You need each one to work separately. And that's what we built here with our demo. Last few words before I show the demo. This demo is currently in a proof of concept model. So performance-wise, it will be perfectly fine. Availability-wise, perfectly fine. The way we overcome a challenge, specifically right now with injecting routes on site B, is yet to be tested for scalability purposes. So you can't just go with our solution. You can go and deploy it. It's fully supported. You can't just go and now throw 1,000 VMs inside B and to scale immediately. It's still work in progress. Same goal that we're showing here can be achieved in multiple ways. Sudhir mentioned VMSC. Sometimes it might be confusing. VMSC talks about single vCenter currently, and I'm going to show a multi-vCenter solution. So this is a deeper discussion, but the demo is important to see what you can do with network virtualization. And let's go into the demo. And a word of advice, I embedded the demo into the slide, so I hope it will work. Let's try and do this. So here's the architecture of what we did here. We got 2 sites, site A, site B. We have a logical network. So just one thing to say here. Think about this. This is the physical network on each site, which is different physical network, and everything below is virtual. Okay, so everything below is virtualized with NSX. We stretched layer 2 network between the sites for heartbeat. This is easy to do. Oracle Rack nodes only need to speak with each other here, so it's pretty simple. You just deploy the universal logical switch, and they will talk. Okay, no special complications here. And we also deployed the public one that provides all the public IPs, and here we need to allow access from the external network. And we want to optimize ingress and egress, right? We want each one to use its own respective sites, and that's what we did. So we deployed a distributed logical router between the sites. So what it does, if you look here, it provides the same default gateway to all the VMs that resides on the E6 hosts in both sites. But upwards to the physical network, or let's say to the edge device that connects it to the physical network, it shows two different gateways in each site. 5555 to site A, 6665 to site B. Important because I'm going to show in the demo how the packets go through. And we deployed edge devices that provides access to the physical world. Let me continue this. In each site. We paired with OSPF, you can use also BGP, site A's logical router control VM with the edge devices and with the physical. So the network actually, the 333 network that we deployed as the public network, actually lives in site A. And on site B, what we're doing, we didn't pair because we didn't want to publish the 333 network from site B. We basically injecting routes with automation. I'm not going to show the automation right now. You can come to the booth. I'll show you that. But basically, we're injecting routes into the edge device and for specific IPs for the Oracle rack on site B. This is where the scalability that we're working on, injecting those routes. But basically speaking, if any user here wants to talk with the Oracle node on site B, the physical router will know that these IPs live here because the edge device taught it. It's called /32 routes, and will know how to pass through the right infrastructure. And we enabled local egress, so packets that come in goes through the same site respectively. Let's go to the demo. We got two vCenters. Each vCenter resides on its own, in its own physical site. This is not a nested demo. We actually use physical infrastructure in two separate places. We got a cluster here. What I want to show here specifically, I start every demo by showing there's no smoke and mirrors. We actually have this stuff working. I'm not doing any kind of quirky things. So I'm showing that site A's physical switch has specific physical network, which is 10.128.136.137/22 network, and site B is going to have a different physical network. And this is to show that if you would deploy Oracle Rack on those two data centers, it won't work unless you're going to virtualize it with NSX, right? NSX provides the ability to stretch that network and provides the same IP scheme on both sides. We got the Oracle Rack nodes. Rack node 1 that resides on site A. I'm showing it has its own IPs. It got the public IP, it's got the VIP IP, it's got the scan IPs. Interesting part about the scan IPs, they can pop up in every node in the Oracle Rack cluster as they see fit randomly. So we had to take care of that as well when we created this. And we got Rack node 2 with its own IPs over there. So these are the IPs for Rack node 2. Movie's going, okay. Just so you know, it's good that we recorded this a week after. There was a problem with our data center, with my physical servers, and it's completely deleted, so we have it on tape here. So I'm going to go into the Oracle Rack node 01. And we're going to run a command that Sudhir very gracefully gave to me to show that Oracle Rack is running with network virtualization in a stable manner. So the 5 milliseconds requirement, everything works and fits. So you see all the services on Rack node 1 are stable. And we're going to go now into Rack node 2 that resides on site B that I showed to you a second ago. Oh, we're going to check the IPs. So the IPs that I showed are the actual IPs. We're going to ping from Oracle Rack node 1 to Oracle Rack node 2. And then we're going to Oracle Rack node 2. We're going to do just the same command with the stable services or not. And then we're going to go into the NSX part showing how we configure this and how the route injection works. So So going to Oracle Rack 2. This is the node. Again, no smoke and mirrors here. These are the IPs that we showed before. And stable services. So we got Oracle Rack working in both sites. Well, Oracle Rack working stretched across sites using NSX with the same subnet between them. Now let's go to the NSX part. If you haven't seen ever how you manage NSX, you go for the vSphere client, and we go to the NSX side. Here I'm going into the edge management, and I'm showing the distributed logical router on the primary site. So I'm going to click into the primary site, and I'm showing this is the universal distributed logical router that is stretched across the site, as you can see here down. Double click into that, and we created, as I mentioned before, 3 interfaces on this, 3 virtual interfaces on this. We got the 333.250, I can see from here, 254, which is the default gateway presented to all the VMs. And we got the 555 on side A and 6665 on side B as the default gateways towards their devices. Now on site B, this is where we inject the route. Sorry, site B, this is where we do all the route injection. This is the interesting part of this demo, the most interesting part. Double click into this. Going into the routing part side of the edge device, you can see all the static routes that we created on it for the Oracle Rack Node 2 IPs. Right? If we trace route now to Oracle Rack Node 1, which is 333.63, you see that it goes from site A's infrastructure. It goes through the physical router, the edge devices, into the Oracle Rack Node 1. If we trace route to site B, it goes through site B's infrastructure. Now, if we go and delete a route, we're going to show it manually, but we did it also with automation. You can do it with REST API or the VRO or Python, whatever you want. We delete the route. Immediately, the edge devices are going to they're going to advertise to the physical router that that VM is gone from site B. And now, if we're going to trace it, you see that it will go from site A rather than site B. So it automatically defaulted back to site A. We didn't get a ping back, even though the VM is still there, because it went through site A to site B, but then tried to return from site B, and that's called asymmetric routing. That won't work for you. Now we're going to add the route back to the VM, to the edge device. So we're going to tell it, hey, to get to 333.64, go through 6665, which is the default gateway on side B, and the transit network that's on side B. Publish that. And after like 1 or 2 seconds or microseconds, depending on your network, you're going to trace, and you see that it's now back to site A. So you can take this is stretching network with software, and deploy it as many times as you want, manipulate it with APIs. This is you can fully automate it, and it solves a big problem that requires big hardware just by using software with NSX. So that was one use case, one demo. Did you like it? Awesome. Yeah, so we have time for useful collateral. We have time for questions. We've got a microphone here, and don't forget to put the evals. That's what they pay us for. Go ahead, please. Questions. Would love to answer the questions.